JC vectors is tough. This is why we need to revise it. Over here, I have a ACJC question, which actually tests you on a lot of your basic vectors concepts that you learn in J1. So let's take this opportunity to recap and also teach you how to solve these type of very unorthodox questions. So over here, feel free to pause to read this question. But essentially what we have is that we have three vectors and we are told that they are all not collinear, right? Point A, B, and 0 and C are not collinear. So why the question actually tells us that is because they don't want us to assume that the points are on one straight line, and if the points are on one straight line, then actually it will hinder us from using this value over here to calculate something meaningful. So now that we know that they are not collinear, it means that technically speaking, if let's say this is 0 and then this is A, I'm just going to draw a line over here, and then let's say this is B over here, right? There will be some sort of angle between them, right? And I'm just going to call it theta because they're not on the straight line. There's some sort of angle between the two different vectors, right? And we are told that modulus A is root 10, modulus B is 20, and A dot B is 40. So if A dot B is 40, that means mod A, mod B, cosine theta will be 40. Sub in these values here, I have root 10 times 20 times cosine theta equals to 40. I bring everything over to the left hand side and I end up with cosine theta equals to 2 over root 10 over here, right? Of which I can find out what's my theta first by cosine inverse 2 root 10 over here, and I get an intermediate value of 0.88607 ... radians, right? I'm just going to store this in my calculator first because later I will need to come back to use this value over here. Now the next point over here is that we have point N, and point N has a position vector of this. So we can see that point N is a combination of A and B, right? And so if let's say ON equals to 5A plus 3B divided by 8, we can say that ON is 5 over 8A bar plus 3 over 8B bar. So if I were to just do a simple plot on the diagram over here, point N would probably be somewhere around here, right? Let's say N is here, right? It has a characteristic of both A and B. So now the question is asking us what's the exact area of triangle ONB, of which we know that ONB is this triangle over here, right? Starting from O, we shoot out to N, and starting from O, we shoot out to B. So the formula for the area of triangle in vectors is as such, right? Area of triangle will be half modulus ON times OB as such, right? And of course, from here we can sub in the values that we already know. So this will be 5 over 8A bar plus 3 over 8B bar cross, then here will be B bar, right? And the good thing about cross over here is that we can expand it to get 5 over 8A bar cross B bar plus 3 over 8B bar cross B bar over here. Now note that B bar cross B bar has a value of 0 because that means that the angle between the two different values are 0, right? The degree is 0 or the radians is 0. And remember that cross product would mean that it's mod B sine theta followed by your normal vector, right? So if the angle between the two different vectors is 0, sine 0 will effectively give you a value of 0. So from here we just need to focus on 5 over 8A bar cross B bar over here. And from here we just need to sub in the respective values, right? A cross B bar would be mod A, mod B, sine, and then the angle between the two different vectors over here, right? Which is what we got over here. So 0.88607 ... radians. And since this is modulus over here, modulus essentially is just trying to find the value. So we can ignore the normal vector because we are not trying to find a normal over here. We're trying to find the area. So in the end, we get half times 5 over 8 times root 10 times 20 times root 3 over root 5, right? So now from here, what we have just done is that we have just converted this over here into this, and from this point onwards, it's just simply just combining everything, right? So numerator times numerator, denominator times denominator, and when you do this whole multiplication, you end up with 25 root 6 over 4 as the final answer to this question over here. So I actually really like this question that is set by ACJC because it really tests you on your basics of vectors, such as your cross product, your dot product, and even your understanding of area of triangle, right? And in JC Math, it is imperative that you get a lot of practice, and not only just a lot of practice but exposure to a wide enough database of question types so that whatever question that come out in the exam, you would have already done it once or twice before you actually sit for the exam. And if you like to get access to my database of a lot of JC questions that cover a range of different question types for all the different chapters, make sure to WhatsApp this number over here, the word library, and I'll send you details to my library that I've consolidated over the past 2 to 3 years at A1 Math Academy called the Library of A1 Math Academy. You will get access to the learning portal, 24-hour turnaround marking service, and most importantly, all of the video recorded lessons to all questions like this and more. More information, WhatsApp over here, and I'll send you on WhatsApp.